Hey, AP Bio. Okay, so we're going to take a look at the second group of free response questions for topic one, the group B ones. And so the first question focused on the properties of water. And basically, what we wanted you to do in this, or what the AP people wanted you to do, is to talk about the cohesive properties of water, how that affects cell membranes, and then there was that graphic on DNA that we wanted to do some analysis on. So the first piece is here. It says water is cohesive. Define cohesion and explain the chemical interactions and properties that make water cohesive. So you had to talk about what cohesion is, the property of water sticking to itself. Same molecules are bound to each other, and it occurs through hydrogen bonding. Why does this happen? Because water is polar, right? Water is polar because it has unequal distribution of the electrons across the atoms, so that the electrons tend to hang around the oxygen atom more so than the hydrogen atoms, and that results in differential charges across the molecule. The hydrogen bonding occurs because of the slight negative charge on one molecule being attracted to the slight positive on another. Okay, and so that allows water molecules to be cohesive because the molecules of water, they're going to form hydrogen bonds with each other. And that was 4 points there. The second part B, was also 4 points. And they wanted you to describe and discuss how water exerts the effect of the arrangement on the cell membrane. So we know phospholipids form membranes and they're amphipathic, which means that they have a polar and a nonpolar end. Because water is polar, when you put phospholipids in an aqueous solution, they orient themselves so that the nonpolar tails point inward. Okay, this is this last bullet, and they are internal, and they're shielded from the surrounding water, right? And the polar heads turn themselves outward, so they're exposed to the water, so that they can create a bilayer. Okay, where the heads are on the outside facing the water, tails are on the inside. Okay, and then the last piece was about the graphic of DNA and the solubility data on the bases. And so we know DNA is stable. Um, it's soluble in water in the nuclear environment in the cell. So they want to know what allows uncondensed DNA to maintain its molecular arrangement. And the fact that we know it's in a polar situation, the phosphates on the outside, they're charged. Remember, DNA has a negative charge. And so those are going to interact with the water. Um, Deoxyribose is a sugar, that's also soluble. Okay, but what happens is the bases, when you look at that chart, the bases are either insoluble or slightly soluble, which means that for the most part, they're really not going to interact well with water. And so they're tucked on the inside of the molecule. And in doing so, that keeps them safely stored away from the water. Okay. And so the hydrophobic bases or the less hydrophilic bases are pointing on the inside away from the water where they're interacting with each other. Okay. And that's it for that question. And then the second question asks you to just describe the two forms of protein secondary structure. Okay. And we know you have an alpha helix and a beta sheet. The alpha helix is the coiling of the carbon backbone. The beta sheet, the backbone, forms these alternating folding patterns. And what forces hold these together? Hydrogen bonds. Okay. It's the hydrogen bonds between the various polar regions of the amino acids, which are going to determine the secondary structure. Most of that hydrogen bonding is occurring between the carbonyl carbon oxygen combination and a hydrogen bound to either the nitrogen or the oxygen. And then at the molecular level, when you take hemoglobin and heat it to an extreme temperature, you can see right there, you're going to disrupt the hydrogen bonds. And by disrupting those hydrogen bonds, you cause a change in the conformation of the protein. You disrupt the active site and any other regulatory or catalytic regions, which decreases the ability of the hemoglobin to carry oxygen. And if you denature it enough, it completely stops. Okay, so those are your answers. Take a look at those, compare them to what's in the free response sections that we put up on Schoology. And if you have any questions, send us an email. Okay, good luck, guys, this week. Free response question 3 needs to be completed today, and we'll post the answers tomorrow. Okay, have a great day. Bye, guys.